Hello friends. Hello friends. Today we will see the topic radiation mechanism of antenna, which is the part of unit number 1. Now here we already defined the definition of antenna, and here we know very well that the antenna is always be radiating the signal. Then here we need to understand how the particular antenna can radiate the signal in a free space medium. So here we need to observe the why does antenna radiate. So there are few points one should be understand properly. The first one is that if a charge is not moving, the current is not created and there is no radiation. If the charge is moving with the uniform velocity, then there is no radiation. If the wire is straight and infinite in extent, there is a radiation if the wire is curved, bent, discontinuous, terminated or truncated as shown in figure. So actually the acceleration and deceleration of charge change in velocity. If the charge is oscillating in a time motion, it radiates even if the wire is straight. So here the conclusion is that there are two important conditions one should be understand. Number one is that the particular wire should have the different shapes, and second one is that your charge which is applied to the antenna or to the wire, it should be oscillating in nature. So the first figure shows the curved nature of that. Here the charge is uniformly moving one, but where it curved properly at that point, here the particular acceleration and deceleration of charge takes place, and that's why it start radiating the signal. Second figure in that it is the wire is bended here, and the point at which it bended, where from that point it start radiating one. Then third figure shows that it's a discontinuation of the particular wire. So cross sectional area of this wire is a less one, whereas the cross sectional area of this particular wire is more. So the point at which the particular discontinuity we observed over there, so this shows the radiation mechanism over there. Next one is that the terminated one, which is not equal to the Z0. In that case also the radiation is possible, and last one is the truncated one. So this is all about how the antenna is radiating the particular signal. Then the displacement of the current. So whenever we are applying the particular sinusoidal signal or oscillating signal at the inlet of the particular antenna, the current flows through the circuit, and obviously the charge will be developed over there. So these are shown here in a figure A. If the wires are separated properly, then the charge will be developed in a curved manner, and if it is a vertical manner, then the charge will be moving on from positive to the negative. And here according to that, the particular displacement of the current we can observe one. So conduction current is always equal to the displacement current. Then here the next point is that how the particular current distribution takes place in a different antennas that we need to be observed one. So in that case specifically, if you see there are three different types of the mechanisms which are used over there. One is called as the two-wire transmission line, second one is called as the flared transmission line, and third one is called as the linear dipole. Now in that case, if you see the simple transmission line, in that the particular signal will be developed over there, and according to that we are applying the AC source with the certain frequency. So here the forward manner signal is available, and this one is the backward manner signal is available, and some kind of standing wave ratio will be generated over there. In a flared transmission line, the end of the particular line is a little bit opening one, and according to that the forward and reverse waves will be traveled one, and according to that some standing wave ratio will be generated. Third one is that exactly the linear dipole, where the dipoles are open and vertical manners are available, and according to that whatever the charge is developed on that specific dipole, according to that the particular charge develop the particular electric field over there, and it start radiating the particular signal. So this is all about how the current distribution takes place on a thin wire antenna. Then the radiation mechanism. Now specifically we know very well that the particular signal will have the sinusoidal signal we are applying one, and according to that particular sinusoidal signal, here we get it the time duration of the particular signal t, and another one is the it having the wavelength lambda. So we know very well that the time duration and the wavelength is the same one for the entire cycle. Now how the actual radiation takes place from the antenna, that we need to be understand properly. So for that we are applying the signal to the inlet of the dipole, where the first quarter part we are focusing on that. So in a first quarter part the particular signal start from 0 and moving towards the maximum peak value. So the duration is t/4. So in that case, whenever we are applying the first quarter of the particular signal, then the charge developed on the first dipole is the positive, and on a second dipole is the negative one. According to that, we know very well that the charge is flowing on from positive to the negative, and this is the dark line which are shown over there, which are simply moving on from positive charge to the negative charge. For simplicity purpose we are showing it only the three radiation components over there. Then after that, whenever we are applying the particular second quarter of the cycle over there, the particular charge will be particular signal will be decreasing on from positive peak to the 0 value. So in that case the charge is altered exactly. So on a top one it gives the negative, and at the bottom one it gives us the positive one. Now in that case, whenever we are observing the particular signal, again the mechanism is functioning same one, and here the charge will be moving on from positive to the particular negative component, which are shown in a dash line. So this is the second quarter of the cycle takes place. Now here the question is that how the particular signal will be radiated from the particular antenna. So as soon as we know very well the charge is exactly the cycle at t/2 exactly 0, 1. So here the particular there is no charge available on the antenna, and that's why the particular signal will be detached from the specified antenna and it start radiating in a free space mechanism. Another one example is that here the antenna and the electric field is shown. Here it's a sinusoidal signal we applied, and the electric field the charge will be mentioned over there, and this is the positive charge and this is the negative charge. So positive charge is the moving on towards the negative charge is a downward, and it is a upward direction. Now here whenever it moves and it oscillates the signal properly, you can see the downward direction which is very close to P2, and the upward direction which is very close to the P0, and P1 is the center of this particular closed loop, and it start radiating the particular signal. This is the particular signal field which are shown over there. Electric fields are shown by the blue color, whereas the magnetic fields are shown by the red color. Both the components are orthogonal with each other. This is the radiation mechanism. Here it shows the clear-cut idea about how the particular signal can be radiated from the dipole itself. Then the current distribution on linear dipoles over there. if you see the very small dipole over the length of L less than lambda value, the triangular current flows through the particular dipole itself, and here we can see that the shape of that is the triangular manner, which is maximum to the I0, which is maximum to the I in value. If the length of the component is lambda by 2, then we get it a perfect radiation of the particular signal. If the length of the dipole is lambda by 2 less than L less than lambda, so in between the lambda by 2 to the lambda value, then the current distribution takes place like that. If it is more than that, lambda to the 3 lambda by 2, then the current distribution takes place like that. Now here the point to be noted that if the length of the dipole is properly selected, then according to that the proper radiation will be possible one over there. Then if you see the particular cycle over there, you can see in the first one t is equal to 0, the maximum current I0 will be developed. Then if t is equal to t by 8, then the current will be half to that 1 by root 2 to the maximum value 0.707 I0, and exactly at t by 4, here the current will be 0 over there. Then another cycle for that it start negative peak 1, and that's why the particular current will be developed in the opposite direction of that. So first one is a 0, then grown up to the 0.707 I0 and grown up to the maximum value of I0. Half your dipole lambda by 2. So in that the length of the dipole is lambda by 2, where lambda is the operating frequency, operating wavelength of the signal, and we can calculate f is equal to c by lambda. It is a resonant antenna, which is the basic principle adopted over there as a resonance. Input impedance Zin is equal to 73.42.5 J. Radiation resistance is 73 ohm, and impedance matching is done by reducing its length till inductive part is vanishes. And this is the shape of the dipole, and this is the particular we can say the current and electric field will be developed over there. Thank you very much.